Which programming language is really closer to the machine? Is it assembly, C, Java, or C#? Let's break it down. People usually split languages into two groups, low-level and high-level. But in reality, it makes more sense to think of them in 4 layers. The lower you go, the closer you get to the machine. The higher you go, the easier it becomes, but also further away from the hardware. At the very bottom, you have low-level languages like machine code and assembly. In the middle, mid-level languages like C and C++ that still allow hardware control but are more portable. Above that, high-level managed languages like Java and C#. And finally, at the top, very high-level scripting languages like Python and JavaScript, super easy to use but very far from the machine. Let's start with the assembly. Assembly is the closest language to the CPU. Each instruction maps directly to a machine instruction, but it's tough, time-consuming, and completely architecture-dependent. What does architecture-dependent mean? Every processor has its own instruction set. For example, assembly for Intel x86 is different from assembly for ARM. Even older CPUs like the Motorola 68000 had their own assembly. So if you write code for x86, it won't run on ARM. You'd need to rewrite it for that architecture. Is assembly the only language close to the system?
I don't think so, darling.
No, it's not. But it's the most widely known, and the one humans can still read while talking almost directly to hardware. There are also languages like VHDL or Verilog, which are used to design FPGAs and digital circuits. The difference is simple. With assembly, you tell the CPU what instructions to execute. With VHDL, you describe the hardware circuits themselves. VHDL is about building hardware. Assembly is about controlling an existing CPU. Now let's go one step higher. C. It gives you almost the same control, but it's portable. You can compile the same program for different architectures. Development is also much faster. And with modern compilers, C code is often optimized to be nearly as fast as assembly. Now we get to Java. Java was created by Sun Microsystems. Its slogan was, "Write once, run anywhere," meaning you could write your code once and run it on any system with a JVM, the Java Virtual Machine. But here, you lose direct control of memory because the garbage collector manages everything for you. So is Java on the same level as C? No, it isn't. Java is higher level because it runs inside a virtual machine and adds more abstraction. C is a mid-level language, much closer to the machine and without a garbage collector. In terms of closeness to hardware, C is much lower and closer. Java is higher and easier. Now let's move to C#. The story started when Microsoft wanted its own version of Java, tied directly to Windows. But Sun didn't allow it. After legal battles, Microsoft abandoned that path and created a new language, C#. In the early days, it looked a lot like Java, which is why many people called it a copy.
Huh?
In the first versions, C# really did look like Java, but today, it has features Java got later, or still doesn't have at all. By default, memory is managed by the CLR and garbage collector. But if you really need to, you can go into unsafe blocks and use pointers. That's rare, but it shows C# can still work closer to memory when required. In one of my previous videos, we compared the C language family. And the reason I said C# belongs to that family is simple. Its syntax comes straight from C. Braces, if-else, loops, operators, even pointers in unsafe mode. Java itself also comes from C. And honestly, most modern languages trace their roots back there. So finally, are Java and C# on the same level? Yes, both are high-level, managed, garbage-collected languages with huge ecosystems. Their main differences are in design philosophy and modern features. And one level above them, languages like Python. Python is extremely simple and readable, great for beginners, and has a massive ecosystem. AI, data science, web, you name it. But it's very far from the machine. Python code runs on an interpreter, not directly on the CPU. You get development speed and readability, but not raw performance or hardware control. At each level, we could also mention other languages besides the ones I covered. Low level, assembly for x86, ARM, and MIPS. Mid-level, C++, Objective-C. High level, Go, Rust, Kotlin, Swift. Very high level, JavaScript, Ruby, PHP. So there's a wide variety of languages across the spectrum, not just the few I explained here. Tell me in the comments, which language do you work with the most, and why do you think it's the right choice? I also made another video explaining the differences in the C family of languages. Check it out if you're curious. And don't forget to like and subscribe so you won't miss the next videos coming up.